Namaskar. In today's world, data is widespread, and with it comes the need for the methods to analyze and draw insights from it. There are many places where statistics play a vital role. But before we start our discussion on the importance of statistics and its graphical representation, let us focus on the book Mathematics Textbook for Class 9th by NCERT. We may begin our topic by asking some inquiry-based question to check their previous knowledge, like what is data handling? After receiving satisfactory responses, we can tell them more about data handling. Data handling refers to the collection, management, processing, and analysis of information from various sources for purposes such as decision making, research, or problem solving. Data handling refers to the process of managing, storing, manipulating, and accessing data in various formats. We can also tell our students that where statistics is used in our daily life, like weather forecasting, medical studies, sales tracking, sports, traffic control, manufacturing, investment, etc. After this, we can explain our students the meaning of statistics. Every day we come across a lot of information in the form of facts, numerical figures, tables, graphs, etc. These are provided by various sources like newspaper, magazine, television, and other means of communication. It may be, for example, related to cricket scores, profits of a company, temperature changes, etc. These facts or figures, which are numerical or otherwise collected with a definite purpose, is called data. The extraction of meaningful information from these data is called statistics. Thus, statistics deals with collection, organization, analysis, and interpretation of the data. The next thing we need to tell our student is about collection of data. This can be done in two ways. As first, we have primary data. Data collected for a definite purpose or by a group of investigators directly is called primary data. Example: 5 students of a school collect data about the height of 50 plants in the school which were planted in the previous month. Secondary data. Data collected from a source which already had the information stored. The data thus obtained is called secondary data. Example: Census Department of the Government of US has stored various kinds of information about the citizens of the country, and we can have data for a definite purpose from this stored information. After this, we will explain some basic terms related to statistics which they have studied earlier. Data. It refers to the individual units of information. Observation. Each numerical figure in the data is called an observation. Frequency of an observation. The number of times a particular observation or a specific value occurred in a data set is called its frequency. Range. The difference between the maximum and the minimum value of given observation is called range of the data. So, range equals to maximum value minus minimum value. Frequency distribution. A frequency distribution is a representation in a graphical or tabular format that displays the number of observations within a given interval. This is of two kinds: discrete frequency distribution, continuous frequency distribution. Let us first understand about discrete frequency distribution table with the help of some example. Consider the arrayed data and form a discrete table with tally marks. So we can see in this data, the number 1 appears 4 times, so its frequency is 4. The number 2 appears 3 times. The number 3 appears 2 times. The number 4 appears 5 times. The number 5 appears 2 times. The number 6 appears 3 times. The number 8 appears 1 time. And the number 9 appears 1 time. Let's now understand about continuous or grouped frequency distribution. Consider the following example. First of all, the data is arranged in small groups. These groups are known as classes. The number of classes depends upon the range of data and the class size taken. Range is the difference between maximum and the minimum value of data. Let the data be arranged in class size of 10. Thus, range equals to 112 minus 14 equals to 98 and class size equals to 10. Thus, we have to make 10 classes. Let's discuss a few important terms regarding classes before looking at the frequency table. Lower limit. The starting number of every class is called its lower limit. Upper limit. The maximum number of every class is called its upper limit. Class intervals or class size. The difference of upper and lower limits. Thus, by continuous method, we obtain the following frequency table. As we can see, we have the intervals from 14 to 24, then 24 to 34, 34 to 44, and so on. One thing we should tell our students while calculating the frequency between the intervals, that the upper limit is not counted for a given interval, only the lower limit is counted. So suppose if 34 is the number in the data, so it will be included in the class interval 34 to 44 rather than in 24 to 34. Similarly, if we have a number 44 in the data, then it will be included in the class interval 44 to 54 instead of 34 to 44. This thing goes for all the intervals except for the last interval. Let us now talk about the graphical representation of data. A frequency distribution table presents raw data in a condensed form, which is not easy to understand for every person. Yet it is easy to understand more clearly than raw data. The main features of frequency distribution can be easily presented with the help of graphical representation such as bar graphs, histograms of uniform width and of varying widths, and frequency polygon. Let us first understand about a bar graph. A bar graph is a pictorial representation of data in which usually bars of uniform width are drawn with equal spacing between them on one axis, say the x-axis, depicting the variable. The values of variable are shown on the other axis, say the y-axis, and the heights of bars depends on the values of the variable. The number of rectangles will be exactly the same as the number of values in the numerical data. The height of each bar is proportional to the numerical values of the data. It represents the numerical values of the data on a scale selected suitably. Consider the following example in which a family with a monthly income rupees 20,000 had planned the following expenditures per month under the various heads. We draw the bar graph of this data in the following steps. Note that the unit in the second column is 1000 rupees. So 4 against grocery means rupees 4000. We represent the heads on the horizontal axis choosing any scale since the width of the bar is not important. But for clarity, we take equal widths for all bars and maintain equal gaps in between. Let one head be represented by 1 unit. We represent the expenditure on the vertical axis. Since the maximum expenditure is rupees 5000, we can choose the scale as 1 unit equals to rupees 1000. To represent our first head, that's grocery, we draw a rectangular bar with a width 1 unit and height 4 units. Similarly, other heads are represented leaving a gap of 1 unit in between two consecutive bars. Thus, we get the bar graph of the given example in this form. Let us now discuss histogram of uniform width. This is a form of representation like the bar graph, but it is used for continuous class interval. In this, a series of rectangles are constructed having their widths equal to the widths of the classes and heights or lengths which are selected in such a way that the areas of rectangles are respectively proportional to the frequencies of the classes. By selecting suitable scales on x-axis and y-axis, the rectangles are drawn leaving no gap between the consecutive rectangles. The figure drawn appear like a single solid figure is called histogram. Let us understand more about histogram with the help of examples. Consider the frequency distribution table below representing the weights of 36 students of a class. Draw a histogram for the above data. Let us represent the data given graphically. We represent the weights on the horizontal axis on a suitable scale. We can choose the scale as 1 cm equal to 5 kg. Also, since the first class interval is starting from 30.5 and not 0, we show it on the graph by marking a kink or a break on the axis. We represent the number of students on the vertical axis on a suitable scale. Since the maximum frequency is 15, we need to choose the scale to accommodate this maximum frequency. We now draw rectangles of width equal to the class size and lengths according to the frequencies of the corresponding class intervals. For example, the rectangle for the class interval 30.5 to 35.5 will be of the width 1 cm and length 4.5 cm. In this way, we obtain the graph as shown here. Now let us consider another situation different from the previous situation in which the intervals are of varying lengths. A teacher wanted to analyze the performance of two sections of students in mathematics test of 100 marks. Looking at their performances, she found that a few students got under 20 marks and a few got 70 marks or above. So, she decided to group them into intervals of varying sizes as follows: 0 to 20, 20 to 30, 60 to 70, 70 to 100. Then she formed the following table. A histogram for this table was prepared by students as shown here. On carefully examining this graphical representation, we come to know that it does not represent the data correctly and is misleading too, since the areas of rectangles are not proportional to the frequencies in the histogram. This happened because the widths of rectangles are varying and the histogram above does not give a correct sequence. It shows a greater frequency in the intervals 70 to 100 than in 60 to 70, which is not the case. So, we need to make the certain modification in the lengths of the rectangle so that the areas are again proportional to the frequencies. Let us see the steps to be followed. Select a class interval with a minimum class size. In the example above, the minimum class size is 10. The lengths of the rectangles are then modified to be proportionate to the class size 10. For instance, when class size is 20, the length of rectangle is 7. So when the class size is 10, the length of the rectangle will be 7 by 20 times 10 gives 3.5. Similarly, proceeding in this manner, we get the following table. Since we have calculated these lengths for an interval of 10 marks, in each case, we may call these lengths as proportion of students per 10 marks interval. So the correct histogram with varying width is given here. There is yet another visual way of representing quantitative data, and its frequencies. This is a polygon. To understand it, let us consider the previously discussed histogram and join the midpoints of the upper sides of the adjacent rectangles of this histogram by means of line segments. Let us name the midpoints as B, C, D, E, F, and G. When joined by line segments, we obtain the figure B, C, D, E, F, G. As polygon is a closed figure, so we assume that there is a class interval with frequency 0 before 30.5 to 35.5 and 1 after, that is 55.5 to 60.5, and their midpoints are A and H respectively. Thus, A, B, C, D, E, F, G, H is the frequency polygon corresponding to the data.
Now, a student can ask you a question that what is the use of adding two intervals, one in the beginning, one at the end, since there is no interval given in the question. So, we can tell them, firstly, polygon is a closed geometrical figure, and secondly, the areas of rectangle should be equal to the areas of the polygon. We can tell our students that there is another way of making frequency polygon by using class marks. Let us understand about it with the help of some examples.
In a city, the weekly observations made in a study on the cost of living index are given in the following table. Draw a frequency polygon for the data above without histogram. Since we have to draw a frequency polygon without a histogram, let us find the class marks of the classes given in the table, that is 140 to 150, 150 to 160, and so on. So, for the first class interval, the class mark is given as class mark equals to upper limit plus lower limit divided by 2, that equals to 150 plus 140 divided by 2 equals to 290 divided by 2, which gives 145. Similarly, we can find the class mark for all the class intervals and we can get the new table as now. To draw the frequency polygon, we have to take class marks on the horizontal axis. Frequencies should be taken along vertical axis. We have to plot the points which are combination of class marks and frequencies as B 145,5, C 155,10, D 165,20, E 175,9, F 185,6, G 195,2. Then we join these points by line segments. We also have to mark the point corresponding to the class 130 to 140 as A 135,0 and for class 200 to 210 as H 205,0. So the resultant polygon will be A, B, C, D, E, F, G, H.
Till now, we have represented the data in various forms through frequency distribution table, bar graphs, histogram, and frequency polygon. Now the question arises, do we always need to study all the data to make sense of it, or can we make out some important observations from it by considering only certain representatives of the data. This is possible by using measure of central tendency.
What is central tendency? Central tendency is a descriptive summary of a dataset through single value that reflects the center of the data distribution along with the variability of a dataset. Although it does not provide information regarding the individual values in the dataset, it delivers a comprehensive summary of the whole dataset. Generally, the central tendency of a dataset can be described using the following measures. Mean or average represents the sum of all values in a dataset divided by the total number of the values. Median, the median value in a dataset that is arranged in ascending order, that is from the smallest value to the largest value. If a dataset contains an even number of values, the median of the dataset is the mean of the two middle values. Mode defines the most frequently occurring value in a dataset. In some cases, a dataset may contain multiple modes while some datasets may not have any mode at all. Let us understand them one by one with the help of examples. Mean. Let us first understand mean with the help of an example. 5 people were asked about the time in a week they spend in doing social work in their community. They said 10, 7, 13, 20, and 15 hours respectively. Find the mean or average time in a week devoted by them for social work. The mean of the above data can be found by the following formula. Mean, that is x bar, equals to sum of all observations divided by total number of observations. That is equal to x1 plus x2 plus x3 plus x4 plus x5 divided by 5. Here, x1 is equal to 10 means value of first observation. Similarly, x2 equals to 7, x3 equals to 13, x4 equals to 20, and x5 equals to 15. So, mean equals to 10 plus 7 plus 13 plus 20 plus 15 divided by 5, which gives 65 upon 5 equals to 13 hours.
The next measure of central tendency is median. The median is that value of the given number of observations which divides it into exactly two parts. So when the data is arranged in ascending or descending order, the median of ungrouped data is calculated as follows.
When the number of observation is odd, the median is the value of n plus 1 upon 2th observation. For example, if n equals to 13, the value of 13 plus 1 upon 2, that is the 7th observation, will be the median. When the number of observation is even, the median is the mean of the n by 2th and n by 2 plus 1th observation. For example, if n equals to 16, the mean of the values of 16 by 2th and 16 by 2 plus 1th observation, that is, the mean of the 8th and 9th observation, will be the median.
After this, we need to make sure that we explain about median with the help of some examples. So let us take some examples to understand about median.
The heights in centimeter of 9 students of a class are as follows: 155, 160, 145, 149, 150, 147, 152, 144, 148. Find the median of this data. First of all, we will arrange the data in the ascending order as follows: 144, 145, 147, 148, 149, 150, 152, 155, 160. Here, n equals to 9 is odd. So, median equals to value of n plus 1 upon 2 observation, which gives value of 5th observation, which is 149 centimeter. So, median height is 149 centimeter. Let us take another example to understand median more clearly. The points scored by a Kabaddi team in a series of matches are as follows. Find the median of the points scored by the team. Solution: arranging the points scored by the team in ascending order, we get 2, 5, 7, 7, 8, 8, 10, 10, 14, 15, 17, 18, 24, 27, 28, 48. There are 16 terms, means n is even. Median will be taken as a mean of middle two terms. Here, the middle two terms are 16 upon 2th and 16 by 2 plus 1th, that is 8th and 9th terms. So, median is the mean of 8th and 9th terms. That is, median equals to 10 plus 14 divided by 2, which gives 12. So, the median points scored by a team is 12.
The last of the measure of central tendency is mode. As previously discussed, that mode is the most frequently occurring value in a dataset. Let us take an example to understand it with more clarity.
Find the mode of the following marks out of 10 obtained by 20 students. Solution: we arrange this data in the following form: 2, 3, 3, 4, 4, 4, 5, 5, 6, 6, 6, 7, 7, 7, 9, 9, 9, 9, 10, 10. Here, 9 occurs most frequently, that is 4 times. So, the mode is 9. You can also suggest some activities or projects to the students related with statistics. I have given here 2 ideas for the activities and projects. You can try your own projects or activities also.
These are some suggested ways of teaching statistics, which may be executed to teach each specific topic of statistics. By following this, we will be able to complete our topic in a stipulated time and can also take queries from the students. We can also assess students' level of understanding within the time period. With this, I would like to conclude our today's discussion. Namaskar.